Here we have another problem. This problem now involves cube roots. And I'm wanting to subtract these problems that have cube roots, but their cube roots are not the same. But maybe I can go ahead and extract a factor out of a cube root, or extract a square out of a cube root. So I have 2 cube root. Rewrite 16 as an 8 times a 2. And I chose 8 because that's my highest perfect cubed number that I can think of that's also a factor of 16. Minus 4 times the cube root. What are factors of 54 such that one of them is a perfect cubed? How about 27 times the 2? Now that I was able to find some factors that were perfect squares, I can pull out a cube root of 8, which is a 2. Cube root of 2 is left. 4 times the cube root of 27, which is a 3, with the cube root of 2 that's left. So I have 4 cube roots of 2, take away 12 cube roots of 2. Now that I have like indexes, like radicals, I'm left with negative 8 cube roots of 2. And that's my final solution for this particular example. Alright, let me show you another problem. Say I have 5 cube roots of xy squared plus a cube root of 8 x to the 4th y to the 5th. I got to start dealing with x's and y's and z's and all these other alphabet letters. Alright, cube root of xy squared. Well, there's nothing in here. I can't break down x any deeper or y squared such that there's any perfect cubes in there. That problem is done, or that side is reduced as far as it goes. And I know for some of you it's going to take some practice back on the previous sections to kind of see that and understand that. That's something that's not really intuitive by just looking at it, watching me do the problem. You're not going to have confidence in these until you start cranking out some of these and start to say, wait a minute, okay, I'm starting to see it. I can do this. But that's what I want. I want you guys to do it. What's left over here, I have the cube root. 8 is a cube root number. X to the 4th can be rewritten as x to the 3rd, a perfect cubed, times x. And y to the 5th, I have to write that as y squared times a y. Oh, I'm sorry, y cubed to y squared. And now I was able to break down all of these individual numbers into perfect cubes. So I have 5 cube roots of xy squared plus, here I can take the cube root of 8, which is a 2, the cube root of x cubed, which is an x, the cube root of y cubed, which is a y, and then what's left inside is an xy squared. And you can see that now that both of my cube roots are the same, which means I can add them together. I have 5 of these guys plus 2xy of these guys. How many guys do I have? I have 5 plus 2xy guys, or cube roots xy squared. Now that problem has been added and reduced and simplified as far as it will go.